Everyone, today we are going to learn into one of the most elegant and foundational algorithm in machine learning, that is decision tree and the very classic ID3 algorithm. Before we started our presentation, I want to think about how you make your decision in your daily life. When you wake up, you don't run a complex question in your head because today is uh, not good weather in. So to decide if you need an umbrella, do you need or not, then you ask yourself some questions as well. Is it raining? If yes, then you ask yourself, is it heavy? Then yes, then you take the umbrella. This sequence of logical steps is exactly what we are learned today in this decision tree topics. This lecture was put together. This is me, I'm the Shamim, ID 12 and 1838. Let's get started our presentation topics. Firstly, define our terms formally. A decision tree is a supervised machine learning algorithm that looks and acts like a inverted flowchart. We call it tree, but in computer science, trees grows upside down. The root is the top and the leaves are at the bottom. Let's break the structure this structure of the tree. The root node, the internal nodes, and the branches and the leaf node as well. So first I want to say you what actually root nodes. This is the starting point. It presents the very first question you ask, and it contains your entire data set before your division happens. Internal nodes, think of this your intermediate test points. Each internal node tests specific attributes or features if your data like humidity or wind. Branches, these are the outcomes of your tests. If the test is it is sunny, then branches are the answer yes or no. They split your path. Leaf nodes, this is the end of the line. A leaf node holds the final classification or decision. Once you hit a leaf, there is no more questions to ask. You have your answer to play or don't play. And then consider a real life scenario. Let's put it into a concrete context. Imagine we are building a classifier to predict should we go out and play cricket today based on today's weather. Our inputs are the things we can easily observe outside. The outlook. Outlook means it is sunny, overcast, or raining. Humidity and the humidity. It is high or normal, and the wind. It is strong or weak. Uh, look at the subtree visual on the right side of the slide. It if we look at window, is it is sunny, our tree guides us down the sunny branches. Now we have a new question: how is it humidity? If the humidity is high, we follow the branches that leaf of the note says no, it is too hot and sticky to play. But the humidity is normal, we follow it to leaf node that says yes, we can play. On the other hand, look at the overcast branches. If it is overcast, the tree immediately says yes to play cricket, because whenever it was overcast, we always played cricket in this cricket here. So now we construct the traditional algorithm, that is ID3 algorithm. So how to actually build one of these trees from the raw data set? We can just guess which question to ask first. We need an algorithm. This is ID3 algorithm, and ID3 is a greedy top-down algorithm. Greedy means it makes the absolute best choice right now at the current steps, without worrying if it will cause issues later down the line. The code of ID3 revolves around the mathematical loop. It calculates overall disorder of the system. We call it entropy. It measures how much the disorder drops if we split the data by a certain attributes. Then we call it information gain. Then it selects the feature with the highest information gain and makes it at the first node or starting node. It repeats the process recursively for the remaining half data set until it runs out a feature of the remaining data is perfectly pure. Entropy concept. We say in entropy is concept brought from the thermodynamics. In machine learning, it measures the level of impurity, disorder, and uncertainty in our data. Look at the formula. Entropy of S is summation of P of probability of I log to a probability I. Here Phi represents the proportion probability of the classic target dataset. And let's ground it with the analogy first. Imagine a box contain 100 balls. If 15 balls are red and 15 are blue, the box is highly disordered because there is no certainty. You have no idea which color you pull out. The entropy at its maximum 1. But if the box contains 100 red balls and 0 blue balls, the box is perfectly pure. There is 0 is uncertainty. When we to pull the ball, it's obviously red ball. The entropy is 0 for this perspective. Our goal is to ID3 algorithm is to drive entropy of a subset down to 0. There is no uncertainty. So now information gain, and we can measure disorder using entropy. How do we decide which feature is the best split? We use information gain for that. Think information gain is the answer to how much cleaner does my data get if I split using these specific questions. And the formula is very simple: old entropy minus new weighted entropy. Uh, that you are seeing in the slide of calculation, some reducing information calculation, then comes to the some step by step calculation. Let's some actual calculation together. uh, Play or don't play cricket. There is 5 days, total instance of 5. Three times play cricket, 2 times don't play cricket. Then now you can calculate the root entropy using entropy equations. It gives you 97, 0.97, and information gained by attributes, outlook, humidity, wind. And in the slide you are seeing that 0.246 highest information gain for entropy. So now information gain, since outlook is the highest information gain, ID3 selects it as our root node. This means outlook is very fast. Most informative question we must ask first. And then if we keep this recursive loop, calculating the entropy and splitting the remaining subset, this beautiful tree is construct that is seen in the screen. You are look at how clean it is. It's if the outlook is overcast, we got straight to play cricket. If it is sunny, then we split humidity. High humidity means no cricket, normal means yes. If it is rain, we split wind. Strong wind means no play cricket, don't play cricket. Weak wind means play cricket. Notice how the algorithm successfully grouped similar past scenarios together to make determines and prediction for future unseen days. It didn't just guesses it, it mathematically partitioned and the feature space to maximize the purity as well. So in to a big we construct algorithm, so there is some advantage that determinants as well. We so first we look at the advantages of the ID3 algorithm. It's computationally fast for discrete distributed, extremely used for humans interest and audit. It searches the space systematically, granting and localized optimal tree structure. And ID3 algorithm some limitation as well. That's it's highly prone to overfitting. It has strong cardinality biases and also the condition variables. It struggles with the continuous variables actually. Some real life application we can use this algorithm in medical diagnosis, assessing physical markers and laboratory findings to identify potential diseases, credit and loan approvals. If we if you want to get give a loan or not, then recommendation system, it's uses in our some browser websites like Netflix, YouTube. After watching a video, you what kind of video want to see next, it suggests you. And then fraud detection, flagging is suspicious activity based on the transaction history, then it detects it's fraud or not. I'm to wrap up our lecture today, let's recap this. In actually, we learned the decision tree mimics human logic, breaking down complex data into a nested binary-like choices. We saw the entropy mathematically, measures the disorder or impurity within the dataset. and we explored the how information gain tells us actually exactly which attribute is the most valuable to split out of the any given, and we walked through ID3 algorithm, which weaves our concept together and build and optimize predictive models. And I want to say something that actually I want to say you that machine learning become easier when decision become visual. That's called my teacher in the lab. Thank you all for your